Okay, in the example number 2 is going to be for the design of a plate type brake for the application described in the example number 1. If the friction torque is 7.232 Newton meter, specify the design coefficient of friction, the dimensions of the plates, and the axial force required. So now we know the omega because we got it from the previous question, and we know the torque. We can calculate the mean diameter if we the main radius, sorry, if we know what the value of the coefficient of friction. So we can suggest that by defining a certain material for our application. So we start with the solution. The first step is going to be, where's my mouse? Okay. The torque is given as 7.232 Newton meter. We are going to try that the mean radian to be 38.1 millimeters. Coefficient of friction is going to be 0.25. And of course, the wear ratio to be 0.116 or 1.1156 watt per millimeter square. So we're going to use the previous equation that we had in the straightforward design procedure to get backward and find what will be the inputs. So now the normal force is going to be equal to the torque divided by the coefficient of friction multiplied by the main radius. Of course, let's just rearranging that the torque is equal to the main radius is equal to the torque divided by the normal force multiplied by the coefficient of friction. So just replace the normal force by the mean radius. So we put all the parameters that we suggested earlier, the 0.25 for the coefficient of friction, 0.038 millimeters for the mean radius, and the torque that's given to us, and we will find that the normal force is going to be 760 Newton. Now we calculate the power. We know the omega, we know the torque. So the power is going to be equal to 586.83 volts. Now for the suggested value of the WR has been given, now we can find the area because you remember that the power divided by the area is the WR. We know WR, so we can calculate the area. So the area is going to be equal to 5,076.38 millimeters square. Now let's try that the RO is going to be equal to 1.5 RI. And from there, we can find the value for the RO and the RI and calculate the area and see if it's going to be the same as the area that we found from the previous step. So 2 Rm is going to be equal to 1.5 Ri plus Ri, and this will give me as 2.5 Ri. And then the Ri is going to be equal to the Rm divided by 1.25. And this will be equal to 30.48 millimeters. And the RO is going to be 1/2 of this value, which is 45.72 millimeters. The area in that case is going to be 3,648.29, which is too low compared to the one that we calculated in the previous step. So in that case, let's go back and suggest a new value for the RO in terms of the RI. We're going to use 2. And by redo the calculation, we will find out that the value for the RO to be 50.8, the RI is 25.4 millimeters. Calculate the area once again, it's going to be 6,080.49, which is okay. Now this one is comparable to the one that we calculated by using the WR and the power. Okay, thank you very much.